Okay. Okay. Good morning, one and all. I take this pleasure of inviting you all for IEEE GB State Student Chapter 2-day workshop on linear control system analysis and design with MATLAB Simulink, organized by Department of EEE, G. Pullaiah College of Engineering and Technology, Kurnool. I I take this immense pleasure to introduce our today's resource person, Shri J. Prem Kumar Garu, Product Manager, MathWorks, Capricot Technologies Private Limited, Hyderabad. Welcome you, sir. Sir has around 10 years experience in MATLAB in Capricot Technologies as a MATLAB trainer. He holds a master degree in VLSI system design and BTech in electronics and communication engineering. Sir is also a specialized trainer in the field of dynamic system modeling, embedded systems, robotics, image processing, speech processing, deep learning, and computer vision. Along with as a MATLAB trainer, Sir has also experience in semiconductor manufacturing industry. We are very glad to have such an talented, eminent speaker for us for 2-day workshop. So I request all the students to utilize this platform and gain as much knowledge as possible with sharing your uh, doubts and gaining knowledge from Prem Kumar sir. Thank you, sir. Sir, HOD sir.
Okay, madam. Thank you, madam.
Now I request Prem Kumar sir to take over the session. Thank you, sir.
Thank you, madam.
Thank you, madam.
Thank you all the participants. Let me share my screen. So before starting, is my voice audible? And can you see my screen?
Yes, sir. Audible, sir.
Screen, sir. This is MATLAB 2021. Is it visible? Sir, is the screen visible?
Yes, sir. Yes, sir. Yes, sir. Visible, sir.
Okay, so let's start our session.
Yes, sir. Yes.
So here I'm using MATLAB release 2021A, and this is the MATLAB that is available for the complete campus. So every student, every faculty, every research scholar can use this MATLAB software. It's free of cost. You all can install the MATLAB on your personal laptops, on your personal desktops. And also this is the MATLAB that is available in our laboratories also. In all departments, we are having the MATLAB. So everyone can install and they can use. And the same MATLAB can be used on your mobile phones also. But coming down to the mobile phones, it will be the countdown version we are going to have. That means all features are not available. And also you can use the MATLAB online. If you're not having the desktops, if you're not having the laptops, then you can log in into online MATLAB and you can use where you can execute by using the cloud-based. So these facilities are available. So every student, I request you all to utilize this facility. So all students, it's free of cost. The only thing is you need the MathWorks account. Once you have the MathWorks account, you can log in and you can utilize this facility. You can use this MATLAB. So coming down to today's session, we are going to discuss about MATLAB and Simulink. For electrical department, Simulink is very, very important. So I'm going to focus my attention more on the Simulink. And gradually I will take you towards introduction about the linear systems, how to model the linear time invariant systems, and how to handle the control concepts for these LTI systems. So for these 2 sessions, I'm going to balance myself and I'm going to take you with the concepts which are been produced with the MATLAB, and also I will focus more and more on the syllabus oriented. So here first, this is the environment that I'll be using, where towards my left side, I'm going to have the current folder. The middle window is known as the command window. Towards my right side, I'm having the workspace. This environment I'll be using for today and tomorrow is the same environment that I'll be using. So here the MATLAB can be customized. Sometimes the workspace will be available towards the left side bottom. Sometimes one of the window will be closed and so on. So what it is, I wanted to customize my MATLAB and I wanted to place these three windows one beside the other. And for my convenience, I want this environment. Within the command window, if I will go and type down a equal to 10, which is an instruction, I can execute this instruction by pressing down enter key. Then immediately MATLAB executes. And you can see the result that is being displayed on the command window, which says as a equal to 10. And within the workspace, towards the right side, we are having the workspace. And here you can view the variable that we have generated just now. So here we are having a variable and its value is 10. Its value is 10. Coming down to the C programming language, if at all I wanted to do the same thing, that means if at all I wanted to generate variable A and assign the value of 10, the process will be in this way. First, I have to declare my variable A saying as int A float A. Then only I'll be going in assigning the value. So first the declaration of the data type is very important. Then I will be going and assigning. But coming down to the MATLAB here, it's very simple. By default, MATLAB takes the data type to be of double. Since we are having the default data type, that's why I have not declared. So whenever I'm going to execute a equal to 10, so we are going to have the double data type. So we are going to have more than 16 data types in MATLAB. We are going to have more than 16 data types in MATLAB. So here, if I'm able to observe within the workspace, just I will resize my window so that I can give you an idea. You can observe I'm having name, value, size, bytes, class. So underneath the class, we are having a double. We can have one more data type, which is single of. So here I'm going to give the same numerical value, which is 10. Now B variable is available within the workspace. And here you can see for this, we are having underneath the class single and the memory it is occupying is only 4 bytes. That means half of the memory I'm able to save. In this way, I can generate the unsigned integers and also signed integers. So C equal to uint 8 and let me give the value of 10. And within my workspace, again, I'm having C variable. Just now we have generated. Underneath the class, it says as unsigned int 8 and the memory it is occupying is only 1 byte. So unsigned integers, there are totally of 4. So let me focus my attention on this unsigned and signed integers. D equal to uint 16 and let me give the same value of 10. And here I can terminate my statement with a semicolon so that I can suppress the results to be echoed on the command window. Just focus your attention over here. D equal to uint 16, the same value I'm giving, but I'm going to terminate my statement with a semicolon and I'm going to execute by pressing enter key. Immediately MATLAB is executed. The result is not echoed onto the command window, but D variable is available within the workspace. So here I'm having unsigned int 16 underneath the class and the memory it is occupying is 2 bytes. Similarly, I'm going to have unsigned int 32 and let me call this one to be of E. Same value I'm going to give. Similarly, I'm going to say it as unsigned int 64. And I'm going to assign this one to the next variable, which is F. So let me execute. So here you can see I'm having unsigned integer of 32, 64. So these two, if you're able to see underneath the byte, it says as 4 bytes and 8 bytes. So let us start from 8. So when I've declared unsigned int 8, the memory it is occupying is 1 byte. For unsigned int 16, it is occupying 2 bytes, 32, 4 bytes, 64, 8 bytes. So over here, when I'm declared with the unsigned int 8, actually I'm allocating the memory. That means I can do in this way. So let me set as x equal to unsigned int 8, but I wanted to give the value of 1000. I want to give the value of 1000. That means I wanted to assign 1000 value. By executing, x is consisting of only 255. Why this is happening means, when I have declared unsigned int 8, the memory that I have allocated is only 1 byte. So the maximum value that I can save is only 255. The minimum value will be 0. That means from 0 to 255 I can save. Higher than 255, I can't save it in unsigned int 8. That's why MATLAB has provided 4 types, which is unsigned int 8, unsigned int 16, 32, and 64. If you are going to save the higher values, then you can choose the higher data types like unsigned int 64. Similarly, I'm going to have the signed integers. G equal to int 8. Let me save 10. Now here you can see I'm having the variable G, which goes with int 8. And here we are having the value to be of 10, and the memory it is occupying is 1 byte. So whenever we are going to do in this way, so let me place this one in the alphabetical order. So G is consisting of 1 byte. Similarly, I'm going to have int 8, int 16, int 32, and int 64. Now let me go and let me say it as y equal to, let me use int 8, but let me try to save 1000 value. Just like previously I have done, x equal to unsigned int 8 of 1000. Now let me execute, and now it is saving only 127. Why this is happening? When I'm saying 1 byte, it consists of 8 memory locations. If it is a signed integer, 1 bit will be allocated for the signed bit. That means to represent the positive numbers and the negative numbers. The remaining 7 bits will be allocated for representing magnitude. So with the 7 bits, the maximum value that I can save is only 127. In this way, we are going to have the data types. So let me say my college equal to. So within the single quotes, just write down over here your college name. So simply I'm typing down this one to be GP set. Now here you can see college goes with, and then the class you see it's a char. So this is a char data type that we have declared. Similarly, I can say in this way. So in MATLAB, few variables are predefined. Already error has been occurred. So I'm calling this one to be true. Then immediately I have generated the logical data type. It's a logical data type. True will be represented with 1 and false will be represented with 0. Have I taken the action? Let me say, no, I have not taken any of the action. Then this is the false. So false will be represented with 0. So if you're able to see, we are having double data type. Then we are having single data type. Unsigned int 8, 16, 32, 64. Similarly, int 8, 16, 32, 64. Char data type, logical data type. Totally 13 data types that we have seen. In this way, in MATLAB, we are having more than 16 data types. So if it is directly declaring a equal to 10, then by default, MATLAB generates double data type. If you are in need of other data types, explicitly mention them. Here, I have utilized the workspace to know the details about the variables that I have generated. So for me, workspace is very, very important because workspace tells me about the information of my variables. With this understanding, let's go with one more concept. Till now, I have assigned a single numerical value to my variable, saying as A equal to 10, B equal to 20, and so on. Now let me assign the subject marks to a student. So let me assume that in a semester, there are 5 subjects. So the marks the student has secured in this way, let me assume 21, 22, 23, 24, 25. And if I'm going to execute, now here you see, coming down to the student, observe the value consists of 21, 22, 23, 24, 25. Underneath the size, it says as 1 by 5. And the class I have declared is double. The memory it is occupying is 40. Each value goes with the byte that is allocated for the double, 8 bytes. Totally 5 numerical values. So 8 into 5, we are having 40. And also we can observe the minimum value is 21 and the maximum value is 25. So along with the variable information, we are going to have the information like the minimum value, maximum value, and few statistical information also. What exactly that I have done over here with the student is, I'm able to go and create a new column by using the space. I have arranged 21, 22, 23, 24, 25 with a single row and in columns. So I have created a new column by using the space. I can create a new column by creating a space or by comma. Now, instead of placing them one beside the other, I wanted to place these values one below the other. So for this one, let me use capital S student equal to n number of values, enclose them within the square bracket, and I'm going to say 21 semicolon, 22 semicolon, 23 semicolon, 24 semicolon, 25. Now let me execute. Now they have been placed one below the other. You observe MATLAB is case sensitive. MATLAB is case sensitive. Student with all small letters and student with S capital letter, they differentiate. So MATLAB is case sensitive. And here you can observe underneath the size, for the small letter student, it is 1 by 5. That means single row with 5 columns. Coming down the student capital S, it is 5 by 1. That means it is 5 rows with single column. So I can create a new row by using semicolon. I can create a new row by using semicolon. Let me go ahead and create a matrix. So by using the new row creation and new column creation, now let me say 1, 2, 3. With the spaces, I'm going to create a new row. Then I want to go new columns. Now I want to go with a new row, so semicolon. 4, 5, 6, semicolon, new row, 7, 8, 9. Now if at all I'm going to execute this by pressing down the enter key, then a 3 by 3 matrix will be generated. So go to capital A. So here capital A, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. But underneath the size it says as 3 rows, 3 columns. And again, it's a double data type, totally 9 elements. So total memory it has occupied is 72. And if you can observe, the minimum value is 1, the maximum value is 10. Along with minimum and maximum value, few statistical information will also be calculated by the workspace. Automatically, MATLAB does all this for us. So I can view and I can get the complete information about each and every variable. Now let me go and let me say in this way. Capital B equal to 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9. The same matrix I'm creating. But at last, I'm going to terminate the statement with a semicolon. The last termination with a semicolon is to suppress the result to be coded onto the command window. But within the semicolon, I have used the same semicolon to create a new row. Let me execute and explain you. Since I have terminated my statement with a semicolon, so result is not echoed onto the command window. Or in a simple words, result is not displayed onto the command window. But internally, this is the semicolon I have used to create a new row. Now let us go in this way. Here, if you're able to observe the student marks, these are the marks which are going all the way from 21 to 25. So these are the marks. So I can generate the same values in another fashion. Let me call this one to be all capital letter student equal to, I can generate those marks by using colon operator. Student equal to 21 colon 25. Let me execute. Now it's the same values that I'm having. When I've chosen the subject marks of a student, purposefully I've chosen these values to be consisting of within a range. Even there are chances that the student may be scoring the marks in this way also. But anyhow, with a small intention in my mind to introduce about the semicolon, I've chosen the marks to be in a range. To generate the range of the values, you can use colon operator. From anywhere to anywhere, you can generate the values. And the starting value and the ending value will be included. Now you see the initial value is 21. You can see I'm having 21. Final value is 25. I'm having 25. So all the way from 21 to 25, I'm having underneath capital student. So 21, 22, 23, 24, 25. In this way, I can generate the values from anywhere to anywhere. That means, let me say, I want to have the values capital M equal to from 1 to 10. Let me execute. Now you see I'm having underneath the M 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're able to observe the capital M within the workspace, here comes capital M. Underneath the value, it is 1, 2, and so on. Underneath the size, it is 1 by 10. It's a double data type, totally 80. Let me start from 0. Coming down to the next value, let me start with 0. So 0:10. So starting from 1, let me start from 0. All the way going up to 10. Now let me execute. Now n goes with 0, 1, 2, 3, 4, 5, 6, 7, 9, 10. Now within the workspace, once again, if I'm going to check my n variable, now here you can see I'm having 1 by 11, the size. The size is 1 by 11. Since 0 has been included, we are having 1 by 11. In this way, I can create the range of the values. When I'm creating the range of the values, let me assume that I want the values in this way. I want 0, but I don't want 1. Then I want 2. I don't want 3. I want 5. Then I don't want. That means every alternate value I don't want. Other values I need. If this is the scenario, I can do in this way. Capital O equal to, I want from 0 and I want up to 10. But I want every alternate value, so I can make this one to be in between value known as step size, which is equal to 2. So with the step size of 2, I'm generating the range of the values from 0 to 10. And these are the values that are available. How exactly MATLAB has created this one means, just I'm going to explain in a simple words. First, it picks up the initial value and it is going to compare with the final value. So final value is 10. In comparison, this initial value will be accepted as a result if at all it will be less than or equal to 10. So compare 0 with 10, it is less than, so 0 is now available as a result. For the result 0, the middle value step size will be added up. And again, it will be compared with the final value. And it is accepted as a result under one condition, it should be less than or equal to the final value. So 0 plus 2, 2. 2 is compared with 10, is less than, so accepted as a result 2. Again for the result 2, step size 2 added up, again compared 4. Again for 4, 2 added up, compared 6. Again 8. Again for 8, step size 2 added up, it will be 10. Result will be accepted if it is less than or equal to. So since 10 is equal to the final value, so 10 is accepted as a result. For the 10, again 2 is added up. After comparison, it will be 12. So 12 is greater than 10, so it terminates. In the same way, I can have the step size to be of 3 also. Now you see I'm having 3, 6, 0, 3, 6, 9. So again, initial value, it is less than 10. So I accept as a result. For the result 0, 3 added up, compared, okay, 3. Then I'm going to have 6. Again for 6, 3 added up, in comparison, 9 is less than, so 9. Again for 9, 3 added up, in comparison it is greater than, say, 10 minutes. In this way, I can have the step size to be of 5 also. Even I can have the step size to be of 8 also. Now just you see what exactly we have done. Initial value, okay, accepted. For the initial value 0, the result 0, 8 added up, compared, it is less than, so 8. For the result 8, again 8 added up, it will be 16 comparison. 16 is greater than 10, so it is terminating. In this way, I can have the step size to be of 10 also. Now I'm having 0 and 10. Equality is also accepted. Even I can have the step size to be of 11 also. Nothing goes wrong. But anyhow, I'm going to have only 0. Because for 0, once step size has been added up, it is greater than 10, so it terminates. So in this way, even I can have the step size to be of a fraction also, like 0.5. Now let me execute. Now you see I'm having 0, 0.5, 1, 1.5, 2, 2.5, and so on up to 10. Even I can have the step size to be of 0.1 also. That means I'm going to have 0, 0.1, 0.2, 0.3 up to 1, 1.1, 1.2, 1.3, all the way up to 10. Even I can have the step size to be of 0.001 also. That means milli. In this way, I can generate the values. Okay. Now I'm going to use the shortcut. Now let me generate these values in this way. 0:0.001 up to 20. Since I know these values, let me terminate my statement. Now within the workspace, now you can see I'm having the values which is all the way going from 0 to 20. Minimum value, maximum value, 0, 20. But what is the step size? 0.001. That means I'm having the value 0, 0.001, 0.002, 0.003, 0.004, all the way up to 20. So totally 20,001 values I have generated. For each and every value of this t, I'm going to calculate the sine function. So here we are going to have x equal to sine of t So sine is MATLAB inbuilt function, and all MATLAB functions are with small letters. All MATLAB functions are with small letters. Now let me go and let me execute. Now here X is generated. For every value of the t, sine has been applied, whatever the result it has associated with X. In this way, even X is consisting of 20,001 values. Now I will go and I will visualize my X variable with respect to t. So plot t comma X. Let me execute. Then immediately MATLAB is going to open up the figure window and is going to display this output. Now let me do one thing. Y equal to cos of t. Y equal to cos of t. Now let me visualize the y variable with respect to t. So whichever is the independent axis, first it should come first. So t comma, now the dependable, let me execute. Now with respect to t, this is the y variable. So sine and cosine will be within the range of -1 to 1. Now you can see this one. But t is ranging from 0 to 20. Now you can see the axis values also. Now let me go and let me do in this way. Even we can have the 3D plot. For this one, plot 3, t comma x comma y. Now this is the 3D plot that we are going to have. Even I can interchange the variable saying this x comma y comma t, by which I'm going to have the output in this way. Just to see, I'm going to have the output in this way. In this way, I can go and I can visualize the variables. In this way, I can visualize the variables. And MATLAB is very good in plotting. MATLAB is very good in plotting. Now, once I have done this, let me close this. Let me close. And let me clear. Now I'll go to home. Here I'm having layout. Underneath the layout, I'm having command history. But default the command history under closed. But I will select the first option which says as docked. Then there's the command history that I'm having. Now let me just scroll up. As I'm going to scroll up, I have started my MATLAB session today at 9:45. And this is the first instruction that I've executed. This is the second one and so on, just to explain you about the data types. This is a char data type. This is logical data type. Then assigning the subject mask to a student side by side and one below the other, or in some other word, I can call this one. I have created a new column by using the space or the comma. I've created a new row by using the semicolon. With this understanding, I've created a matrix A and B. Then here I'm generating the range of the values with the semicolon. Then this is the step size explanation. Then I'm going with the plotting. So all these programs are important for me. So that's what I'll do is I will go and I will select all this and I'm going to right click. There's an option for me to create a script by which the editor has been opened up and all these instruction has been included over here, by which now I can create a MATLAB file. MATLAB files will be saved with .m and by default the name will be untitled, but let me call this one to be demo_1. Let me save this one. So this is demo_1. So MATLAB files will be saved with .m. So the extension is .m. Now why exactly that I have used about single and so on means, so I can comment. I can use the comments. Comments will be starting with single percentage. Default data type. Now coming down to here. Single data type to save memory. Or even I can go and I can have the comment as a separate line. Here I'm going to say about unsigned data types. Then I will go and I'm going to say from here, these are the signed data types. In this way, I can go and I can add comments with a single percentage. It can be a separate line or it can be after an instruction. So in this way, I can just describe about what exactly that I'm doing. Now, at last, I'll be going in, I'll be declaring about visualization over here. You can see over here, this is about the visualization part. So single percentage, and I'm going to say visualization. And here, this is about the line plot. And also we are going to have the 3D plot. So that's what I'm going to say over here. Three-D plot, and this one is changing the variables order. Change the variable order. So in this way, we can give some description about our instructions or about our program. And also I can say this one to be, we are just concentrating on the basics of MATLAB. Just we are focusing our attention on basis of MATLAB. So I can add in this way. Then I can go and I can observe here, there's an asterisk mark. Since I've edited, asterisk mark is going to appear, which is a reminder for us to save the file. Now let me go and let me save the file. Immediately MATLAB saves, and asterisk mark is going to disappear. Now whatever that we have designed over here, I can add the documentation, I can program, and I can do all this. Now let me go and let me run. So if I'm going to run, the complete program will be executed, and here we are having this output. But since we are having many outputs, let's do one thing. Let me go and let me add the figure concept. So here I'm going to say it as, by which we can capture even this figure also. Since I've edited, once again I have to save it. Once I've saved, now I can run. Now in this way, I'm going to have these outputs. So MATLAB is very good in visualization. Now we are having a new concept known as live script. So here the main purpose, I can use command window to execute single instructions or single functions, but generally 99% will not use the command window. We write down our programs as a .m files and we are going to use. And in the latest version of the MATLAB, we are having a new concept known as live script. The extension of the live script is .mlx, where I can say in this way. So basics of MATLAB. Now I can make this one to be the text. Just I've selected this one. Underneath the live editor, I'm having text option. I can make this one to be the text, or I can make this one to be the code. It's my choice. Let me make this one to be the text. Then I'm having these options. Let me make this one to be the title. Then once this one, here I'm going to concentrate on fundamentals only. And especially I'm going to use MATLAB and Simulink. And the version that I'll be using will be 2021A. 2021A. Now let me just copy this. I can make this one to be the code. If not, I can make this one to be the text. And here, let me make this one to be heading 1. I have made this one to be the heading 1. After that, let me go, let me say A equal to 10, B equal to 20, C equal to A plus B, arithmetical operation, D equal to A minus B, and so on. So these 3 lines are the MATLAB codes. Now I can go select and I can make this one to be the code. If not, I can make this one to be the text. It's my choice. So for me, it is a code. So let me make this one to be the code. Then I want it to go and I want to say about the visualization. And here, this is the visualization, which is my code or text. So right now it's a text, and that I want to make this one to be heading 1. In this one, I'm going to say t equal to 0 colon 0.001 colon 20, x equal to sine of t, y equal to cos of t. Then I can say plot t comma x. Even I can make this one to be plot x comma t. I'm interchanging. So with respect to x, I wanted to visualize t. Okay, let us do. Then I want to say as plot t comma y. And also I wanted to say plot. So let me have 3D plot. Plot 3 t comma x comma y. And also let me have plot 3 x comma y comma t. Just I'm interchanging. Okay, let it be. This is about my visualization. Now let me go and let me save this. Let me go and let me save this. So purposefully, I'm going to save this one as demo underscore one. The extension is .mlx. Purposely, I'm saving this as demo underscore one, but let me save this. So this is the .mlx. Towards the left side in the current folder, you see, we are having two files, which is demo underscore one .m. Previously, we have printed this one by using our command history, and also we have executed. Then just now I created .mlx. Now this is the .mlx I'm having. Okay, now let me go and let me run this. Once I'm going to run, towards the left side, now you can see we are having towards the left side, we are going to have the outputs. Now let me save this. Now let me do one thing. If at all I wanted to execute only up to here, now I can select and I can right click and I can evaluate. Now I'll do in this way. So coming down to here, I'm having towards extreme right side, I'm having three options. The first option, if I'm going to place my cursor, is output on right. The second one, I'm having output in line. And third one, I can hide the code. Okay, let it be in line. And once again, I'm going to evaluate. And if I'm going to check, the outputs are available in this way. Now let me do one more thing. Since the font is very small, you can maximize this one by using Control plus. Just to see if you are with the live script, the option that you are going to have in this way. So once you're able to execute, then there's a live script which will be going with the documentation like this. And also you can have the code and also you can collect the output. So MATLAB supports all this. MATLAB supports all this. So we are having two types of MATLAB files, which is .m file and other one is .mlx file. With this understanding, let me introduce you about interactive plotting. So for this one, let me clear all. So here I'm using a shortcut. If I'm going to place my cursor, in the midway, I'm moving upward. Here I'm having a shortcut. In the latest version, we are going to call this one to be the favorite, where we are going to add our own code. So right now I've included close all, clear all, IMAC reset, and CLC. CLC is the function to clear the command window. Clear is the function to delete the workspace variables. Close all is a function to close the figure windows. That means figure 1, figure 2. And many times I'm going to use the camera for the machine learning concepts. So always I'm going to reset my camera. So that's why I have included one more function known as IMAC reset. So by clicking on this shortcut, I'm going to execute those 4 instructions. Now let me do in this way. Let me say it's a peaks. So this is the output. Let me talk. Now I'll click on the shortcut or the favorite by which I'm going to execute these 4. So the output figure window has been closed, workspace has been cleared, and here command window has been cleared. So in this, I'm going to utilize the shortcut. And a small thing here, I don't know why the output of plot is not available. So okay, here I have done a mistake. Let me run. So let me check only ABC available. So tomorrow I'm going to let you know. Okay. So with this understanding, now let me go to Simulink. Coming down to the Simulink, in electrical and mechanical and also in electronics, we are going to use this very frequently, the Simulink. So to open up the Simulink, I'm at the home. And if I'm going to come in the midway, I'm having a colorful icon which says as Simulink. So I move my cursor, here you can see. So once I'm having over here, so let me use the cursor over here. So once I'm having the Simulink over here, now let me go and let me click on this, by which now the Simulink will be opened up. Based upon your system configuration, to open up the Simulink, it may be taking more than 3 minutes also. So you have to wait. When I have started the MATLAB, only MATLAB has been loaded. Now when I have clicked on the Simulink, now the Simulink has been loaded. So be sure, based upon your system configuration, it may be taking more than 3 minutes. So you have to wait. Simulink will be slower. And for the first instant of the time, when you are going to load the Simulink, always it will be slower. And from the next instant of the time, it will be faster. Once I have clicked on the Simulink, and this is the window that will be opened up, then immediately I'm having 8 options. Among these 8 options, let me select the first option, which is known as Create Model. Click on that. Again, it is taking time. You can see the busy cursor. Then immediately a new white window opens up and previous window automatically closes. A new window has been opened up and the previous window has been closed automatically. Now, once I'm having this window, now here towards the left side top above, you can see it says as Untitled Simulink. Once I'm having this window, I'm going to place this window towards my right side. And I will go and I will check over here. It says as new, open, save, so on. And here I'm having library browser. Let us click on library browser. Then immediately one more window has been opened up. And this window is known as library browser. So let me place this library browser towards my left side. Let me place my library browser towards my left side. Now here you can see I'm having Simulink, aerospace block set, audio toolbox, automated driving, and so on. So many are there. But Simulink is from here to here. Just you can see, I'm going to elaborate. From here to here, it is known as Simulink. Now let us do one thing. In this one, towards the left side, we are having something known as sources. Already I've selected. Immediately towards the right side, the associated blocks for the sources has been displayed. Let me do one more. Just above the sources, towards the left side, I'm having sinks. Just above the sources, I'm having sinks. Let me click on sinks. Immediately, I'm having these blocks. So let me go to sources and let me identify what are the blocks that are there. Among these blocks, I want to use the sign block. So I'm going to drag and drop this sign block. I have dragged and dropped this sign block. Again, there's a small delay. Always in Simulink for the first time, this delay you can observe. Then I go to the sinks. In this one, I'm having display, floating scope, and so on. And there's a scope. So let me add the scope block. So I have selected two. One is the sign and second one is the scope. Now let me elaborate this window. And I'm going to use the space bar so that these blocks will be auto scale. That means these blocks will be fitted to the window size of Untitled Simulink. So to auto scale the blocks, use space bar. Now you observe the sine wave block. Sine wave block is consisting of one small arrow towards the right side. So let me use annotation. So towards the right side, I'm having an arrow which is pointing outwards. Now observe the scope. For the scope, I'm having one arrow towards the left side and it is pointing inwards to the scope. These are the arrows which are telling about the signal flow direction. That means from the sine wave block, the signal is flowing out of this block to the external world. And coming down the scope, the signal is telling that the signal is flowing into this block. Okay. Now I'm going to interconnect these two blocks. For this one, I'm going to move my cursor towards this arrow. Then immediately the cursor turns towards the crosshair. Just you observe. Once it is crosshair, I'm going to left click my mouse and I'm going to drag. Then a red dashed line follows. Actually, that is a red arrow that is following. And as I'm going to approach the scope block, the red dashed line turns towards a black solid line, which is an indication that connectivity is possible. Once it turns to the black solid line, I'm going to leave it, interconnection takes place. Let me do one more time. So I'm moving my cursor towards the sine wave block. The cursor has turned towards a crosshair. Once it is crosshair, I'm going to drag. So I can move around anywhere, but be sure it is still the red dashed line. But anyhow, I wanted to connect to the scope block. So I will just directly move in straight line over here. If the connectivity is possible, it turns towards the black solid line. Once it is black solid line, then I'm going to leave it, interconnection takes place. So this is the sine wave block and this is the scope block. Now we are able to interconnect. There is other way of interconnecting, which is the easiest way. Select the source, press down the control button, click on the destination, interconnection takes place. Once again, I'm going to do select the source, press down the control button, click on the destination, interconnection takes place. Whichever is convenient, you use that one. Once I have interconnected, now let me simulate my model for 10 seconds. So here is the green button, top above, in the midway, green button, let me click. It says a simulate model. So once I'm going to click on that one, then you can see a small changes has been happened to the window. And towards the left side bottom, you can observe it says as ready. So from here onwards, you are going to focus your attention towards the left side bottom and the complete bottom row. So it says as ready. Now I'll go and I will double click on the scope. Then again, it takes certain time and a new window opens up. And this one is known as the scope. And here you are having the output of the sine wave, which is ranging from -1 to 1, which is ranging from -1 to 1. And this is the output that I'm having. Okay, let me close. Now I wanted to know the properties of this sine wave block. For this one, go to the sine wave block and double click. Then a new window opens up, which is known as block parameters. That means this is the window that describes about the sine wave block. It says as sine wave. And here you can see the mathematical formula. So based upon this mathematical formula, this is the sine wave block that is working. It says as output is equal to amplitude into sine of frequency into t plus phase plus bias. In this mathematical formula, I can change amplitude, frequency, time, phase, and bias. So by default, amplitude is 1. You can observe over here. And by default, frequency in radians per second is 1. And other parameters are 0. Now I can go and I can change the amplitude. Let me change the amplitude to 5. Say it as apply, OK. And I'm going to minimize my window. Auto scale, double click the scope. Let me place it over here. Now be sure the sine wave has been, amplitude of the sine wave has been changed to 5. After changing, once again, I have to simulate. So once again, I'm going to simulate. Immediately, you can see the effect on the scope block. So let me simulate. Now the range of the amplitude is from -5 to 5. In the same way, I can go and I can change the amplitude to 25. Say it as apply, OK. Once again, simulate. Whatever the changes you do, once again, you simulate, and this is the output that I'm having. Now, instead of doing this way, let me do in this way. Instead of changing the amplitude, I want to change the frequency. Now, let me change the amplitude to 1, the default, but let me change the frequency. The default frequency is radians per second. Let me change this one to 3. Say it as apply, OK. Once again, simulate. Now, you see, I'm having more number of cycles. I'm having more number of cycles. In this way, I can go and I can change the property of this sine wave block. But anyhow, the default values are amplitude is 1. Frequency in radians per second is also 1, and other values are 0. And by simulating, this is the output that we'll be getting. Now let us go and let us observe one more thing. You can simulate the same model from the scope itself. Within the scope, you can see I'm having this run button. If I'm going to place my cursor, it is a run. So from here also I can run my model. For this one, let me double click, change this amplitude to 5, say it as apply, okay. Now from the scope, here is the scope. I'm going to click on this one. Now I have executed. Now amplitude is ranging from -5 to 5. Now let us go and let us close this and save this model. So here I'm having save option towards the left side top above. By clicking on this one, now it will be saved with the extension of .slx. By default, MATLAB suggests the name untitled. Don't use untitled, use your own name. So save the file with your own name. Now let me call this one to be my sine wave. This is the name that I've given. Okay, let me close this. So now within the workspace, I'm having demo_1.m file, demo_1.mlx file, my sine wave.slx file. So here I'm going to have .m, .mlx and .slx. There's one more thing. So let me go to Simulink. Again, you can see 8 options. Click on the first option. A new window opens up, previous one closes. Now I'm going to library browser. And I will go to sources. And I'm going to select the sine wave. By default, the sine wave is with amplitude of 1 and frequencies in radians per second is also 1. Now I go to sinks and I'm going to add the scope. And here I'm going to interconnect. But be sure, I wanted to amplify this signal. For this one, I go to math operations. You can see we are having absolute, add, and so on. Among this one, I'm going to have product. So here I'm a product. So let me drag and drop. Now I'm going to place this product over here. So this is the product. Now if you are able to observe consisting of, let me maximize this window. So this is a product that is consisting of 2 inputs and 1 output. So here in Simulink, we are going to have the blocks which may be having only the output like the sine wave or only the input like the scope, or we can have the blocks with the inputs and the outputs. Both inputs and outputs we are going to have. And coming to inputs and outputs, again, I can have multiple inputs and multiple outputs also. So here, the product is going to accept 2 inputs and is going to give us 1 output. So I can connect the sine wave to the first input of the product. Now, whatever the sine wave I'm having, the default value of 1 amplitude and frequency radians per second also 1. I want to amplify this one with 5 times. So I go to constant library browser, and here within the sources, I'm having constant. Just you can see I'm having constant. I can drag and drop. If not, if I know the name of the block, I can type down over here. Then immediately you see the options are available. Among these options, I'm going to choose the appropriate block that I may need. So it's your choice. Since you are at the initial stage, so let us go with the library browser only. And here I'm going to drag and drop the constant. Drag and drop the constant. So once I'm having the constant, now I'm going to connect in this way. Now what is this constant? Constant is going to always give us a constant value. The default value is 1. The default value is 1. Let it be 1 only. Now I'm going to set as apply OK. Now I'm going to interconnect the output of the product to the scope. So whatever the sine wave I'm getting, I'm multiplying this one with 1. And here I'm going to view on the scope. Let us simulate. Double click on the scope. This is the output I'm having. Let me resize this window so that I can place the scope block towards my right side. And whatever the changes I'm going to do, directly I'm going to view onto the scope block. Auto scale, space bar. Now the sine wave with amplitude of 1 is coming and multiplied with 1. There is no change I'm having. Within the scope, the output is ranging from -1 to 1. Now I'm going to change the value of the constant to 5. Set as apply and OK. And once again, I'm going to simulate. Now here you can see amplitude is ranging from -5 to 5. Now instead of 5, let me go and let me change this one to be of 25. Set as apply and OK. Now let me simulate from the scope. From the scope, I'm having this option to simulate. Let me click on this, run. Now it is ranging from -25 to 25. Anyhow, let me place this one to be a 5 only. Apply OK. Once again simulate, check. Yes. So this is ranging from -5 to 5. So over here, actually, this is the constant and the multiply block are behaving like an amplifier. Whatever the signal I'm having, here the sine wave, it has been multiplied by 5 times. That means it has been amplified by 5 times. So why can't I treat these two blocks are behaving like an amplifier? So I'm going to select these two blocks. I'm going to place my cursor on one of the block and I'm going to right click. There are many options where I can cut, copy, paste, comment, so many, even I can delete. But I'm having an option known as create subsystem from selection. Let me select that one. Then immediately, this is a block that I'm having. And here, if I'm going to double click, internally I'm having this circuit, which is nothing but one constant and one multiplier. So let me click on up arrow. Whatever the sine wave, it is going to amplify by 5 times. This is what the meaning. Now let me go and let me change this amplitude to 2. Now sine wave is with 2. It will be passed on to this block subsystem. Now what is the output can I expect? Already this amplitude with 5. So amplitude will be from -10 to 10. Now you see, it is ranging from -10 to 10. Now let me make this one, the amplitude to be a 5. Set apply OK. Once again simulate. Now it is ranging from -25 to 25. So whatever the input, this one will be multiplied by 5 times. This is what it meant by. So can I rename this subsystem? Let us give the meaningful names. So to rename, wherever the subsystem in blue in color it is been displayed, click on that. The cursor is blinking. That means it is editable. Now I'll go and I will edit. So I'll call this one as an amplifier. Since it's amplified by 5 times, I'm going to make this one to be 5. Now you see this amplifier 5. If at all I'm going to go and give this value to be of 100, and now amplitude is 100. Whatever the amplitude, it will be amplified by 5 times. Now you see it is ranging from -500 to 500. Instead of giving the sine wave, let us give a constant. So I'm going to library browser. Here I'm having constant. Let me pick up this constant. Input can be anything. Input can be anything. Now what I'm doing, I'm giving 1. So 1 will be multiplied or amplified by 5 times. This is what it meant by. Now let me simulate. So here, scope will be used to display the continuous values. But coming down to the 1 multiplied by 5, it will be a numerical value. So to display the numerical value, we are having one more block underneath the sinks, which is known as display. So we can use this display. So according to my requirement, according to the outputs, according to the signals, I'm going to choose the appropriate blocks. And let me click on the spacebar, auto scale. Now scope is not appropriate to view the constant values. That's why I'm using the display. Once again, let me simulate. Now here you see 1 multiplied with 5, output is 5. Now let me go and let us make this one to be 5. Apply OK. And I'm going to simulate my model. Now it is 25. So if you want to do in this way, now I can go and I can comment this one. And I'm going to run. Be sure the scope is not active now. Only on the display I'm able to do. But if at all I'm going to go and change this one to the sine wave. Now I have to uncomment this one. Now I can comment this. Because, okay, what will happen with this display? Let's check. Okay, now I'm going to simulate. The default values for the sine is in this way. Amplitude is 1. Frequency in radians per second is also 1. Amplified 5 times. I'm going to expect the output to be in this way. But over here, underneath the display, it is picking up the last value. It is picking up the last value. The last value over here will be turning up to be -2.75. But anyhow, we need the range of the values. That's why now I can go and I can comment. And I can use this one. Now let me change this one to 5, amplitude changing to 5. Say it as apply OK. Once again simulate. Now it is ranging from -25 to 25. So in this way, even you can utilize the commenting. So previously we don't have this facility. So we used to face a lot of problem, but now we are having this facility. Whichever you want to do, you can do that one. Now let me do one thing. Let me go back and let me change the amplitude to the default value of 1. Say it as apply OK. Now what exactly that is happening? Whatever the amplitude of the signal that I'm having, it has been amplified by 5 times and it is displaying onto the scope. Let us check. Now output should range from -5 to 5. Now I don't want it to utilize this amplification. Whatever the input, I want it to pass on without processing to the output. If all I want to do one, I'm going to right click and I'm having an option to comment through. Let me click on comment through. And immediately you can see whatever the input that is coming, it is being joined to the output with a straight line. Okay, let us check this one. Let's check. So before that, let me check my sine wave. Amplitude is 1. Frequency is also 1. So what is the output right now? It is ranging from -5 to 5. On the scope, you can see -5 to 5. Now I'm going to simulate. Once again, run. Now this one is ranging from -1 to 1. That means whatever the logic that is having within this subsystem, I'm not utilizing. The input for the subsystem has directly passed down to the output. So if at all you wanted to what we can say in practical application means, if at all I don't want to process, simply I wanted to bypass that one. If at all I want to bypass that one, whatever the logic that is behind that subsystem, yes, I can do that one. So we are going to have two things. One is comment through, another one is comment out. Comment out is nothing but our commenting of an instruction, just like our C program or MATLAB program. If it is comment through, the complete process we are not utilizing. The block will be there. Internal, whatever the logic that is there, or whatever the program that is there, we are not going to use. Simply input will be passed down to the output. So these two are the beautiful features. We can use these two. Okay. Now whatever I have done, now let me go and let me save this. Now here you can see it is always suggesting as untitled, and here you can have the extension. This is .slx. But let me save this with one more. There's a drop down. The older version of the Simulink will be saved with .mdl. So let me save this one with .mdl. Save it as save. But be sure I have saved this one as untitled. I have saved this one untitled. The name I have not changed. Let me do it this way. So there are 4: demo_1.m, demo_.mlx, mysinewave.slx, untitled.mdl. Now what I'm going to do, let me go and let me once again create one of the Simulink model. Then here you can see a warning that is been displayed on the command window. It says as the model name untitled is shadowing another name in the MATLAB workspace apart. That means by the time I have opened up this Simulink, it is starting with the name known as untitled. Already within the workspace, I'm having untitled. So I'm going to face a problem. So that's why we recommend you not to use the default names. Save the files with your own names. So here we are going to face a problem. One. The next one. Let me clear everything. The shortcut I'm using. I'm clearing everything. Now, let me try to open up demo_1.m. This is a program we are having. Now I wanted to run this. So by the time I'm running, be sure .m file I can't run because MATLAB cannot run this file because within this path which says as C drive, GP set, EEE department, demo_1.mlx is shadowing. .mlx file with the same file name if I'm having, I can't execute .m. Then what can I do? No, I can't do anything. Okay, let it be. Let me close this one. Now I want it to run .mlx. Let me double click and open up. Now let me try to run. Let me try to run. Then this has been executed. Now within the workspace, you can see ABC, and here also you can view ABC. Here also you can use ABC. So if you are having with the same file names, but the extension is .m and .mlx, you can't run .m, but you can run .mlx. So make it sure .m and .mlx, both files with the same name, then you can't run .m. But still .m is also very important for me because .m is consisting of lot of information. So that's why what I'm going to do is either I have to copy and paste in some other folder. That means these both .m and .mlx should not be within the same folder. If not, I can rename. To rename this .m file, I'm going to just right click and I'm having an option to rename. And here I'm going to call this one as GP set demo underscore one. So this is the name that I've given. Now, once it is GP set demo underscore one .m, now the .mlx is demo underscore one .mlx. Now let me open up .m file and let me run as I'm having all these outputs. It's perfect. So that's why we recommend you not to use the same file names for the .m and .mlx. One. Now let me go with .mlx. We have to check even the .mlx. So I'm going to open up. Once again, I'm going to run this. And it has been executed. These are the outputs I'm having. Actually, even we have to get for this plot. I don't know what customization I've done. So let me check. Tomorrow I'm going to let you know. Now, similarly, let me go with .slx. Let me double click, by which I'm going to open up this .slx. Now let me simulate this model. Double click as the output is available. Then what about untitled.mdl? Let me double click. So this is the logic we have done. Now let me simulate my model. This is what that I'm getting. So if it is untitled, if at all I want to create a new file, then only I'm going to face a problem. But let me do one thing. Let me go and let me rename this one. And I'm going to make this one to be the same file name. So my sine wave.mdl, this is the name that we are giving. Now let me open up this .mdl. It's commenting out, commenting through. This is what that we have done. Now let me simulate as I'm getting the output. And let me go with .slx. Now if I'm going to simulate this output that I'm, so coming down to the .mdl and STLX, no problem, we can do that one. We can execute. But the major problem, we recommend you to always use .mlx because you can add the documentation and also you can have the output. Now let me do in this way. Instead of this one, let me do in this way. Let me add the inbuilt functions known as peaks. Sorry, what mistake I've done is in this way. Z, Control Z, Control Z, Control Z, Control Z, Control Z. Actually, I have to create this one to be a code. I've forgotten this one. So what I will do is, I have to make this one to be the code. That's why we are getting that mistake. Now let me run. So once I'm having this one, now I'm going to run. So here comes the output. Here comes the output. Anyhow, I have started in this way. So I wanted to say about inbuilt functions, which are predefined. And let me make this one to be the code. Let me make this one to be the text. And here I wanted to make this one to be the title itself, the separate one. Then I want to introduce about peaks and the logo. Now let me just select these two and I have to make this one to be the code. Now let me once again evaluate. Now this is the output that I'm having. Let me save this. So we recommend you to always use the .mlx, that is the live script, because we can have the documentation. Here I'm writing down only a single line, but you can have a paragraph to describe what exactly that we are doing. Along with the documentation, I'm having the code. Along with the code, even I can collect the outputs like this. Towards the right side, you see. So extreme right, if I'm going, top above, I'm having three options. If I'm going to choose the second option, I'm going to collect the outputs in line with my program. Immediately after execution of A equal to 10, whatever the result, it will be displayed. B equal to 20, result displayed. C equal to A plus B, result displayed. Now after visualization, plot T comma X. Immediately the output over here, plot X comma T. With respect to X, I'm plotting T. So we are not habituated to view in this way. With respect to time, we wanted to view the other variable. But anyhow, MATLAB supports in this way. Because in electronics and communication, we are having one electronic component. The characteristics, if at all we wanted to know, with respect to I current, we are going to visualize the voltage. But generally, according to our resistor or so, whatever the voltage we apply, what will be the current we are going to display. So with respect to V, we are going to display I. But there are few scenarios where we wanted to alter also. So MATLAB supports that one. So whichever is applicable, you use that one. Then I'm going with plot T comma Y. Then I'm going with plot 3. Then this is changing of the variables and this is inbuilt peaks and logo. So in this way, I can go and I can utilize the line script for the documentation to have the code, and also I can collect the outputs. So there are many advanced features that are there with the live script. That's why we recommend you all to use the live script. Now, what about the .m? So here I have to explain. So while explaining, just to observe how I have explained. So is this giving more meaning or is this giving more meaning? So this one is giving more meaning. That's why I always advise you to use the .mlx. So anyhow, we are having 4 files. One .mlx, .m. So there's a problem with .mlx and .m. If the .m and .mlx are with the same file names, then you can't execute .m. But coming down to the .mdl, .slx, there is no problem. But anyhow, we recommend you not to use the same file names, though the extension is different. We recommend you not to save the files with the same file names, though the extension is different. So always try to save it with different names only. So I will go and I will rename this one. Older Simulink. And I'm calling this one to be my sine wave. So this is the name that I wanted to give. So now I'm happy. All these are different. At the same time, I want to do one more. So let me clear all. And let me close this one and also this one. Now what I'm going to do is, I wanted to know about the plot function. I want to know about plot function. So previously I have used a plot directly. To know the information about the plot function, just use doc space plot, enter. A new window opens up, which is nothing but the user guide or the help. In this one, the complete description about the plot is available. It says as 2D line plot. There are different syntaxes. In this syntaxes, now here you can see, I can plot in this way. I can have multiple plots. Even if this is the matrix I'm having, if I'm going to use the plot of that variable, I'm going to have so many plots based upon the dimension. Even I can customize the line styles. By default, we are going to have the blue in color, but I can customize the line styles. So complete description is available over here. That means whenever you come across any of the new function, to know the details of that new function, just type down within the command window doc space the function name. Okay, let me say about peaks. Already have used. So let me say doc space peaks. If I'm going to enter, documentation is available. Here it describes about the peaks and also it gives few of the examples. Just you see, these are the examples we are going to have. So MATLAB is very rich in documentation. When you have installed the MATLAB, along with the MATLAB, even the documentation is also been installed. Or in other words, even the documentation is available along with the product. So I recommend you all to utilize the documentation. Okay, let me close this one. Let me clear everything. Now I go with GP set. And here you see, I'm having many programs which are with .m and also .mlx. And these are different folders I'm having. Previously, I have conducted the training program in our college itself. So all this I have utilized. Now let me go with DSP. So many .mdl, .wav, .m. So these are the older files. These are the older files that I'm using. So though I'm utilizing the latest version of the MATLAB, which is released 2021A, the older version of the Simulink models, I can.
Hello, sir. Sir, it is muted, sir. Hello.
Someone has muted me. It's not me.
Yes, sir.
So
Now it's
here, is it audible now?
yes, sir. Now it's audible, sir.
Okay. So here you see, coming down to my previous examples, I'm using the combination of .mlx, .m, .mdl, and so on. So one thing to be noted. Here I wanted to focus my attention on the latest version. And the latest version in Simulink, it supports .slx. So mostly I try to use .slx only. But if at all, I'm having the older programs which I've created long ago. If at all I wanted to open up, then I'm going to open up and I can use with the latest version. But there is a small difference. If I have created a model with the .slx extension, the newer one, but if I'm using the MATLAB, which is a folder, now I can't open up this .slx. So there is a small misconcept that will be there over here, or a small difference will be there over here. So since the college has provided for all the students and faculty the newer version, and there is no limitation with the toolbox and so on, I recommend you all to use the latest version of the MATLAB. The latest version of the MATLAB. But anyhow, just keep in your mind, even the older version of the Simulink models with .mdl, you can open up and you can execute in your version. With this understanding, now let me go to one more concept. So here you can see, I'm having one file. Let me use right click open outside MATLAB. Actually, this is the MATLAB that I have installed on the Samsung tablet. And I'm running the Samsung tablet and I've recorded this one. So the video I'm going to show you, because I can't directly use the tablet over here. I can't demonstrate. So this is the recording. So let me stop. Just I will move back just to show you. Here you can see this is the MATLAB icon. That means on the Android operating system or iOS, you can have this MATLAB can be installed. And now I can use this one. So I'm double clicking, opening up. So this MATLAB will be run on the cloud. And here this is the MATLAB command window I'm having. So I'm going and typing down my program. And I'm executing by pressing enter key. x equal to sin of t. Immediately you can see by the time I have typed on sin, the suggestion is available. Now I'm going with y equal to, by the time I'm going to type down COS, just you can observe top above, the suggestions for the associated or the related functions will be available. I can choose from there. Y equal to cos of t. Now I'll go with visualization plot. So immediately you can see plot 3, x comma y comma t. And if I'm going to execute, you can see the status towards the right side, the output is available. If I'm going to click, it will open on the figure window. It's an enlarged one. Now I go and I will execute one more function. So here I'm minimizing the step size 0.1, previously 0.001. So I'm reevaluating t. That means I'm updating my t value. And also I'm going to update my x variable. So plot t comma x. Now I'm going to customize the line style. By default, it is blue in color, but I want to use another color, which is red, and also the line style, which is asterisk. And I'm going to evaluate towards the right side. You can see the status says as so and so, and this output. Click on the output, it will display onto the figure window. So in this way I can do, but let me go ahead, let me execute one more. So this is the inbuilt function peaks, and this is the output. And let me execute MATLAB logo. So it is predefined, and the output is available towards the right side. Let me click. This is the output I'm having. Now you can see peaks and logo both are available. I can select either to display the peaks or the logo. So these two are available. Now I can select in this way. Now I'll go and execute quit. Now immediately I'm going to have an error because on MATLAB mobile, all functions are not available. That means the desktop version or the laptop version is a full-fledged version we are going to have. Coming down to MATLAB mobile, it is a cut down version. So all features are not available. Even you can get the help also. Getting started, open with help and so on. So all these are available. So even I can use in the portrait mode also. Till now what I have said is about the landscape mode, but let me go. It's the same MATLAB. The portrait mode, if I'm going to use, this is how I'll be getting. Now you can see even the error messages in this one. Purposefully I'm creating one error. So plot x comma y comma t. So these errors will be in red in color. So in this way I can use MATLAB mobile. So if you are having the account, MathWorks account is free of cost, then you can use MATLAB on mobile and also online. So MATLAB provides you all this. So if you're having the laptops or the desktops, you can install this one. So it's free of cost. I recommend all the students and all the faculty and the research scholars to utilize this facility. And you're going to have all these toolboxes. Today we have discussed about this MATLAB and this Simulink. Along with the MATLAB and the Simulink, we are having more than 100 application related toolboxes. So we are having 3G, 4G mobile technology. If at all you want to research with 5G, this is the toolbox. For automobile industry, we are having AutoSAR. Aeronautical department will be using these two toolboxes. For antenna designing, especially EC department will be using this antenna toolbox. For speech processing, we are going to use audio toolbox. For self-driving car concept, we are going to have the automated driving toolbox and so on. In this way, we are having more than 100 application related toolboxes. Tomorrow, I'm going to demonstrate MATLAB online. So today I have demonstrated about the installed version of the MATLAB and the mobile version of the MATLAB. Tomorrow I'm going to demonstrate MATLAB online. So that means within the web browser, you can use the MATLAB. Again, there's a limitation. It is, again, all features are not available just like the desktop version, but still you can go and you can utilize MATLAB online. So I recommend you all to utilize these facilities. So it's already 11:29. It's time for me to wind up my session. Any questions before closing?
Dear students, if any have any doubts or any questions, you can ask to the sir.
So tomorrow it will be on controls. So if you can understand MATLAB Simulink, then we can find easy with the controls. Okay, if there are no questions, then let's wind up our session. Thank you all. Thank you all the
Thank you,
participants.
sir. Thank you very much, sir, for giving a
Thank you, sir.
excellent speech. Thank you very much, sir.
Thank you, sir.
Okay.